Hi, everyone. Today I'll be talking about our kind of ongoing research project for a couple of years now on the RoboBlox, the new kind of breeze blocks. But before I start, I'd like to acknowledge the traditional owners of the lands where we stand as the First Nations. I pay respects to their elders, laws, and customs and creation spirits of Turrbal and Yugur people, and I recognize that these lands have always been places of teaching, research, and learning. So RoboBlox is a collaborative project with QUT and Müge. That's how it started. If you look at the people who are involved in it, it's a cross-program collaboration in a way of the two programs, 2 and 3. And the number of people that gets involved with it's a growing community as well. It's basically, it all started with my postdoc role at the Design Robotics project with QUT and UIP, where it was the first time that I started engaging with the robotics technologies around the year 2018. That grew into a bit about this, my background, and I became part of Arm Hub, where I get to meet with industry, and now I'm part of the Australian Robotics Center. So I guess as a junior researcher who started as a postdoc and growing in this area of research, I have always been part of these very supportive and collaborative groups. So I guess I wanted to discuss the topic of, yes, we know the technology is the answer to our problems in this upcoming world, but as Cedric Bryce puts it, what is the question that we are trying to answer? And we need to really think about how we engage with technology and how we use it, especially in today's conditions with the need for addressing the Sustainable Development Goals. How are we going to allow technology to solve the problems of today and for the future as well? So my research is really looking at these topics, and I guess RoboBlox is a way to address the sustainability goals. So I believe in order to address the issues, we need to be more efficient in our ways of building and constructing. So we need to look at more user-centric methods, more economical ways to actually engage with the users of these technologies. But we also need to find optimized solutions, which are designed and built to use fewer materials, more efficient, more durable, and new ways of efficient ways of constructing. So I guess that's why the way I use the computational methods and looking at design to fabrication ways are the pathway I see in this optimization processes. And we need to look at sustainable solutions. And this is not just looking at sustainable materials and methods, but also involving the existing workforce and allowing novice users to engage with these technologies to have a more sustainable outcome. So most of my research is looking at this type of digital design to physical fabrication. I believe that this way we can empower the designer to be more in control in material manipulation and the manufacturing processes, and also allow opportunities for embedding different systems and sensors into their design workflows. So I use this software called Rhino Grasshopper, which is a 3D modeling software for designers. It was actually initiated by initiative for industrial designers. It was a software that would allow you to do 3D scanning and then also create these more fluid geometries, which are more ergonomic for the human body. So industrial designers started to explore these dynamic forms. And as architecture, we realize as we are thinking in this geometry and the spatial way, we can actually engage with it in a way that we can design any form and then think about the way we can manufacture it. So, you know, find ways to actually create this kind of digital to physical workflows. And then it started to evolve into this visual programming language, which you can see on the right-hand side, where we, again, as designers, we are very visual. So we start connecting different elements, writing some code to bring in other sensors, embedding, you know, Arduinos and other type of things, tools to create that kind of feedback loops from the environment. Going back to RoboBlox, the first opportunity arose when we were invited to participate in this Istanbul Design Biennale. And the topic of the Biennale was a school of schools. So it was about the learning and the teaching of these technologies. And we were invited by this group, Istanbul-based designers called FAB, which had this industrial robot, and they wanted to place it in the art gallery, and they wanted to invite different people from all over the world, so that everybody could show their design thinking and design processes in order to build the exhibition over a period of time. And as part of this proposal, they wanted us to engage with students and run some workshops to be able to teach these technologies. So for us, it was a great opportunity because we were also just about to start our learning of using the robots. We had just purchased our UR10s, and it was a way to accelerate that knowledge for us too. So our team, so the FAB group, they gave us different themes to explore as part of this exhibition, and our team was emergence. So we went back and looked at this Morphola game, which was designed by Thierry Foucault at the time, where they were looking at creating these very organic design tiles, ceramic tiles, and the game was very easy. So you would have a square tile with different edges, and as long as the edges matched, then you could do anything you want within the tile, any organic form, to come up with a very unique bespoke pattern every time you play this game. So we took this two-dimensional game and started to explore and look into ways how we can think about it in a three-dimensional manner. So here you can see Jared and Ellen acting like the robot in the workshop, and looking at ways where we can create these two-dimensional forms. And it was really a hands-on experience around understanding material, understanding how a craftsman would engage with a material process and build upon it through that manner. And then those explorations, we took it to, we wanted to engage novice users because we knew that, you know, robotic processes were not so easy and accessible for people that didn't even have seen a robot before. So the idea was to create this website, and you can still play the game if you go to Jared Donovan .com. You can see the Morphola Games versions there. You can go into this website and design your own patterns, and then the Grasshopper Rhino code would take those patterns as a JSON file from that server and then create a three-dimensional form. So we did some tests with the students. They come up with some designs. This is the website where you can go and engage. So you can see the edges match, and then you can play with the rotation of each tile. You can manipulate the curves as you like, whether you want to have a more geometrical surface or a more fluid surface, and then you can change any tile as you like to design different patterns. And here are some of the examples of what each student could come up with, testing the potentials of such a system. So going from this interface, then we did a demonstrator where this is the first time where we took an existing handheld hot wire cutter, a hobby tool, to go and cut a piece, one of the blocks in our J block. And it was a very exciting day for all the students because they had never seen a robot doing anything in a workshop. So here you can see that workflow. This is the interface of our software where we can see in 3 dimensions what we are designing, and we can also simulate the robot's movements based on that. There are different plugins that you can use. These plugins can, depending on your robot type. So if you are using a KUKA robot, then there's a plugin called KUKA PRC, and it has a very big community around it. It has a forum where you can ask questions and find out what other people have done with the software. There are free tutorials as well. And then, or what we are using currently with our URs, our robots plugin. So that's also an open source plugin where you can control different types of robots like KUKA, URs, FANUC, ABB. So basically it simulates the robot's motion based on the geometry. So this work was we worked on it here with our URs, and then we send the code to Istanbul. And in Istanbul, they use their KUKA robot and their end effector to actually run this in the art gallery. So this is an image from the day when the event took place. And they were saying it was just an amazing experience because people were so curious to see how the robot actually builds things and what are the outcomes. We were very concerned coming from Australia. Our health and safety regulations are much more than it is in Turkey. I don't know if we can do something like this with an industrial robot in an art gallery here in Australia, but yeah, I'll show you another example later on with a collaborative robot. So as part of the exhibition, they also exhibited the materials, the different types of materials, and the different types of end effectors. This was our corner with the wire cutter, and I guess the reason why we chose hot wire cutting was that it was the easiest tool that we can start making things. We didn't have much experience at the time, and we wanted to be able to create an output, and we wanted to translate that hands-on, hobby-like experience to a robot. This was the exhibition piece, which was being built in the gallery and exhibited there. After this exhibition in 2018, we were invited to be part of the Brisbane Art and Design. And this time we had a chance to actually think a bit about how we can utilize this system as designers ourselves and to be able to build it and present it in a different manner here in Brisbane. This was our exhibition corner. We had this big kind of a wall mural, in which some of the parts are now here behind me in the blocks. Half of it, and half of it is leaning on the door here. And we had three parts to our exhibition. We had a video that explained the process of how we engage the novice users and how we build this design process. And we also had this table where we had 3D printed some blocks where the people that come for exhibition could play around and experiment with the designs. And then it was exhibited for a couple of months there. But I guess the biggest concern that I had for this exhibition and the previous one was the material that we had used, because foam is a very toxic material. So when you are working with it, when you play with the material, it starts to create toxic fumes. So I'll just run this in the background. Maybe put the volume down. So it creates toxic fumes. I wanted to move away from this material and look at ways where we can actually build this system in a more sustainable way. So for the exhibition for BAD, we had many pieces. So we used industrial robots at UQ. So this is the UQ lab where we calibrated the KUKAs. So KUKAs are much different than URs. They need a lot more precision and calibration process. So here we are calibrating where the material is, and it's a very tedious process. And then the robot would just go in. I'll just fast forward some of these and cut into the material. There were a lot of learnings about how we can actually use the material, like how the material should, the hot wire cutter. Sorry. Is someone talking to me? I couldn't. Or maybe was it unmute accident. Yeah, so the different materials, I guess things that we had to pay attention was the speed of the robot and then the way it gets into the material. It really has an effect on the way the blocks curve. So there was a lot of learnings from there about the robot's motion and how we can control it. And then here you can see that learning, and there were some minor precision issues that we explored. And then this was the final outcome of the work in the gallery space. Going forward, like I say, I was very concerned with this material, so I wanted to explore other types of materials. So build another type of end effector with Mia at the time and Anthony. And then we used the guitar string to actually carve into the clay. And as the material changed, of course, the frictions change, and then the way the robot responds to that change and the precision of cutting becomes a different story. And this one was exhibited this time. The next, so here you can see how the clay comes out after it's been cut. And then this one was exhibited in 2021 BAD exhibition, but it was just a window display instead of a piece within the main gallery space. And it was a new learning as well. So with clay, we find out that you can't really fire it, so you need to air dry it. But then during the air drying process, the material shrinkage change depending on the different types of humidity within the day. So then the block's precisions might not necessarily be ideal for this kind of a process. And I start engaging with the industry partner, Brickworks, to talk about whether they would be interested in this kind of a bespoke design of a brick element for future collaborations. And that led us to our recent grant with Brickworks for the building for CRC. So this kind of an exploratory process also has other outcomes for researchers. I guess, and for industry as well. The project was then invited to be exhibited in 2020 in the Tin Sheds Gallery in Sydney. For this one, we looked at rethinking our app, our web design. So Jared developed this app that based on the same rules, but we could see the design in two directions much better. We were more in control of the curvatures and the design parameters. And then the system works similar, but this time instead of sending it to a wire cutter, we looked at 3D printing with clay. The geometry would be sliced into a 3D form, and then those slices would be 3D printed. And we also ran a workshop with the users to actually test this app and test this interface. And they were students that have never used a robot or never have used a computational design process. So there was a mixed group. We purchased this end effector, which is from 3D Potter, and we start 3D printing with clay. You can see the different experiments, different learnings, and failures, and learning from failures to actually find out the material qualities, the viscosity, the elasticity, the ideal mix types, and how to be more in control about form and different types of printing processes and layers. And then here are some of the samples, and these ones we could actually fire in a kiln, so they became more like a product rather than experiment. And here you can see some of the, sorry, I just exploded your ears. But you can see the printing process and the way it's simulated in the program. So the way we slice the geometry, it identifies these planes, and then the robot's end effector tip is aligned with those planes, so it just follows that. And this is the way the program simulates for us to be able to use the robot. And because we are all designers, we are familiar with the software, it's very easy for us to actually understand and observe the robot's movement in that way. And if there are errors, it also informs you about the errors as well. So this was exhibited in Tin Shed, and this is from the opening night. So we had the big foam like hanging sculpture, and then we also had our blocks with the failures and the successes, which then led us to this next exhibition, which is just taking place in Delft right now. And we also became part of this group of researchers called She Robots, and Dagmar Reinhardt, Liam Locke, and Deb Term, who is leading this exhibition, and they have engaged with more than 30 female researchers, roboticists around the world to take part in the exhibition. This year's theme, Ecologies of Care, is looking into more sustainable practices. And we this time wanted to explore a bit more sustainable material mixes. Our PhD student, Ahmed, is looking at utilizing the waste that comes out of the local agricultural stream of sugarcane. So he's creating these mixed recipes as part of his PhD. And we managed to use some of that in our printing to actually test the potentials and the challenges that comes with those material mixes. Here you can see the parts. We have 3D printed 36 pieces. We wanted to explore a repetitive pattern that changes over time using our app. And then Each one of them had a different type of a material mix, starting from the bagasse to porcelain clay to algae, and different levels of I say bagasse materials. So some are more textures and some are not. And again, there were a lot of learnings. We packed it and put it in our luggage to take it to Delft, and did a natural compression test with the Emirates taking very good care of my luggage. So at the end, some pieces unfortunately broke, and that was a good learning as well, because we know now what a compression test can do to different material mixes. And here's the final exhibition piece that is now on display. So they show some of the images of the process, but also the final materials. And we also have a video screen with the videos that are explaining the processes. Yeah, and I mean, we don't know where next, but She Robot seems to happen every 2 years. Now we are in conversations with Venice Biennale, so let's see, maybe it will be exhibited in the Venice Architectural Biennale, and we'll be exploring other types of things around the RoboBlox. So that's all I wanted to show you today. And if you have any questions, I'm more than happy to answer. Thank you. I'm checking if there are any questions.
It's very fascinating, and I was wondering if there's how the software works, because I think I missed some passages around how the software operates.
So the way it operates is the users use this app, which is a more like a user-friendly interface. They can design their pattern, and then once they are happy with it, they just save it. It runs on a local host in the computer. It outputs a JSON file. And then that JSON file, which has all the information about the curves and the points that form the geometry, is then transferred into Rhino Grasshopper, where it rebuilds the geometry and then slice the geometry into different layers for the 3D printing to occur, and then sends it to the robot to follow those points on the curves. So it is like a fully digital, physical kind of a workflow.
In which language?
So depending on the robot, the Rhino would output a different file. So for URs work with UR script. So it is output in a UR script file. Otherwise, Rhino Grasshopper runs in its own syntax called Rhino Python. And then you can actually write other codes within that software, like C# or Python. You can develop your own components as well. So depending on the need of your work, you can develop your own code. What we've been using it as part of our group is to communicate it with ROS as well. So we are using a WebSocket to send messages to ROS environment back and forth, so that we can also employ ROS as an alternative way to control the robots.
So that you can intervene after, like, while the robot is working?
Yes.
Or, okay.
Yeah, so it's like a almost real time. I mean, it's not real time, of course. You send a message and it sends it to the robot moves, and it sends the information back. So then you can, and I think Loy's PhD is using that process to, I saw him around here. Yeah, there's Loy. Maybe he can also give us a seminar about this one. That would be good. Thank you for the question.
Thanks.
I mean,
Müge,
yes.
it's John here. Is there a plan to actually make breeze blocks?
I'm
Because that's what
hoping.
we'd all want.
Yes, I'm really, I mean, this was in the first step, I guess, the first time we actually tried it with clay for it to work. And I'm hoping with this new relation with Brickworks, I can showcase this work to them and then see if they have any appetite to take on it. My previous conversations were around challenges about such a bespoke manufacturing. It's so unique that they didn't see relevance because they're a mass production company. I mean, they do customization, but there could be other companies as well who might be interested in this process. It's a very high-end, high-value product at the end of the day.
Hi, Müge, it's Greg here.
Hi, Greg.
One of the really early conversations that we had in setting up all of these wonderful ventures that we've been, traveling through from design robotics was the topic of concrete printing. So printing, for example, decorative elements that would become a tunnel bespoke. So do you think it could scale up to that size? Is there, like, I understand there'd be all kinds of, structural issues and sustainability issues, but
Yeah.
I think is it right to say that the geometry work that you've done, the geometrics and the sort of software workflow that you developed in theory could print a tunnel?
But I mean, yes, I guess it has been like concrete 3D printing is happening everywhere. Not everywhere, but in a lot of places in the world. For example, in Istanbul, the Istanbul municipality developed a printing process for disaster after earthquakes, disaster management, 3D printing for creating houses. And there are some companies in Australia now taking on this technology. There is one in Gold Coast that I'll be visiting. And recently, another building for CRC project, which hasn't been finalized yet, but we are in conversations with a company who's interested in robotic 3D printing of concrete. And I'm collaborating with civil engineers that are looking at more sustainable recipes of concrete, which also embed maybe textile waste from the textile industry, and looking at other additives into the process. So we did do some tests with our existing extruder to print some concrete, but it is on baby stages. Hopefully, if that project takes hand, we will be doing some printing with ArmHub big robot in the next year. So I'm still cross fingers. But it's not going to be tunnels. It would be some more technical things like pits.
Okay.
Yeah,
Sure.
drainage pits.
Very interesting. Great programmatic approach to doing research.
But I mean, I guess if we haven't started this journey with RoboBlox, we wouldn't have got into this stage. So lots of learning from these little exploratory art projects.
Right.
It has a great potential.
Right.
Thank you for the question. I guess there are no more questions. One last thing that we've been doing with John, which is I think quite good or relevant for engineers as well, is we are teaching this software to engineers as part of the honors degree. And it is impressive how they can take on it so fast and start using robots. I might argue much faster than Ross, but But then they get frustrated with it because it's too geometric and maybe it's too slow for them. I don't know. Yeah. So I'm always open for collaboration with different disciplines. All right. If there are no more questions, I think we have 3 minutes, but we can finish early. Yeah. Okay.
Actually,
Glenda has a question.
yes. Sorry, I have a question. With the exhibition at in Delft, what other things were sort of presented, or did the work have some commonalities with some of the other approaches, or how does the project sort of sit within that exhibition and what other people are doing?
There were a lot of 3D printing projects, and a lot of them were looking at different materials. So, for example, there was an exhibition from CITA. They are looking at seaweed as a material for the building industry. So they are 3D printing seaweed panels, and they are looking at how these panels can deteriorate over time, and how we can actually maintain. So they do a lot of computer vision scanning of the panels and then reprinting, because seaweed has that possibility to add on and repair after a while. So they are exploring that. There was a group from Delft with Henriette Bier. She is looking at constructing in space. So she has, her group has made this Voronoi-like 3D printed structure. If you go to the Delft exhibition webpage, there's a catalog as well where you can see these projects. So they are looking at printing with biopolymers and looking at printing with materials from Mars, like how with the, that chemical properties can be utilized to 3D print. So that was quite interesting. There were a lot of projects around human-robot interaction, so it's not just making, but there is that human-robot interaction, like a robot putting a lipstick on a human, or a robot that's helping an aging person, like a dynamic wheelchair that communicates with the person. So it's a great collective, and actually now they are having these panel talks once a week, and it is on, you can access them through YouTube channel. So it's really about knowledge sharing. So I'm very proud of being part of this SheRobot ecology, and the name is SheRobots. Apparently, Dagmar was saying it's a action. Yeah. All right, now we are over time, I think. No, we are just on time. Okay, thank you, and see you all, and yeah, bye.